Hey, how are you? Can you hear me?
I can hear you. Can you hear me?
Yes, and we are live, so I will intro you in.
All right.
Um, cool. Welcome everyone. Welcome to the Technically Developers Conference. I'm Technically Managing Editor Julie Zeglin, and this is Chris White. He's the CTO at Prefect. So what will you be hearing from Chris today? Data tooling typically requires a choice between managed services that provide convenience at the cost of configurability and security, or self-hosted solutions that require deploying and managing a custom tech stack. Learn how Prefect orchestrates millions of data workflows through a unique API-first design that meets users where they are, allowing them to deploy to custom environments without requiring first-class access to proprietary code or data while still enjoying the benefits of a managed orchestration service. So I will let you take it away. Thanks, Chris.
Great. Thanks, Julie. And I believe that if you're here and you have any questions, you can drop them in the Q&A tile on the side. This is my first time using this system, but I'm going to try to keep monitoring that. I should be sharing my screen, and if anyone can't see it, also let me know. But I believe it's being broadcast to everyone. So the abstract that Julie just said is still essentially this sort of thing that I want to talk about today. However, I did want to take a step back, and maybe instead of going into a lot of the details about specifically what Prefect does, I wanted to just establish the problem space that we're in. And so the talk title is slightly different than what it was previously, but still on the same topic essentially. And so title now is, if you give a data engineer a job, the problem with orchestration. So in case you're not familiar, this title is a reference to a very popular children's book called If You Give a Mouse a Cookie. And this book is, just a really cute book about a mouse who asks for a cookie. And then after he gets the cookie, he asks for some milk. Then after he gets the milk, he asks for a mirror to make sure that he doesn't have a milk mustache. And it's, basically illustrating the problem of slippery slopes. And so the thing that I really want to emphasize throughout this talk is that orchestration, in a very unique way, consists of a set of problems that developers and data engineers specifically tend to experience quite often that always feel very simple when you first experience them. So you do the simple thing, you implement something custom, and then very quickly what you find is that you've developed a system that has such sprawling emergent complexity that you just have a ton of tech debt to manage, and you find yourself prioritizing the wrong thing instead of the task that you're actually hired to complete. And so I want to kind of dive into that and do a worked example of what exactly I mean when I say that. So let's start by talking about what is orchestration. So I'm actually not going to give a super precise definition here, but instead I just want to give you a list of features that you've probably encountered before as a developer that I would say fits into the orchestration paradigm. So first and foremost, there's scheduling and triggering of jobs. What those jobs are doesn't really matter. The point is that scheduling is definitely one of the foundational blocks of orchestration. Dependency and state management. So this is an interesting one. Maybe you have a type of job that you only want to run when something upstream fails. Maybe you just have dependencies. So just when this succeeds, this next thing runs. So that's also a type of orchestration. Easy recovery from failure. So this might be a manual thing, just giving you the ability to very quickly rerun, some piece of code, or maybe it's an automatic thing. Maybe it's automatic retries. So, we've all hit brittle APIs before that have rate limits, and maybe you need to take a step back, wait a couple minutes before you send that request again. It'd be really nice if we didn't have to code up custom for loops for that sort of thing. Tracking artifacts, side effects of jobs is usually an important thing that you have. Maybe just a report that you produced, an email that you wrote, or that got automatically sent. Resource management, so memory management, CPU management, this definitely falls under orchestration. Things like Kubernetes help here with things like this, and Kubernetes is a container orchestrator. Observability and visibility, this is a really big one, and we're going to see this come up a lot today. Just the fact that you have something running and you just want to see if it is still running in a healthy way. What that means is very use case dependent usually, but you need some sort of a view into that system. Caching I put into this, so just deciding whether a task should run is really a way of thinking about caching. And if not, should it still return something, which is maybe a cached result of some kind? And there's, a million other things here that fall under orchestration, but just so that we're all kind of on the same page of the type of stuff that we're talking about, this is really what I mean when I say orchestration. And one other thing that I do want to highlight here is that nowhere in this definition do I need to reference the use case that we're actually working with. Today, we're going to talk about data engineering just because that's, the world that I live in the most, but there's nothing unique to data engineering about a lot of the feature list that we see here. So I have a proposal for you all. And my proposal is that orchestration is a subset of something that I'm going to call negative engineering. So, what is that? Have you heard this term before? I'm not sure. So let's first start by defining positive engineering. Positive engineering is very straightforward. It's the thing that we typically think of engineers doing every day, writing code to achieve an objective. So that objective could be to, provision a new database. It might be to move data between two databases for the purposes of a data warehouse, which is the use case we'll kind of dive into a little bit. It's the actual business objective or team objective that you have before you. Negative engineering, on the other hand, is all the other stuff you have to do and all the other code you have to write to make sure that that positive code is actually running in a healthy way. And, you probably immediately know exactly what I'm talking about in your world when I say these two things. There's the task that you care about, and there's all the other stuff you have to do. You find yourself learning about, new tools just because you're protecting yourself against some type of failure mode. And I would propose to you that orchestration is a subset of negative engineering. And so what I mean by that is not that it's a bad thing. It's just that it's not really something you should have to think too much about or be an expert in to achieve your business objectives. Once again, when we go into the example here, we'll see exactly what I mean by this. But writing a scheduler or a dependency resolver is not a good use of time for someone who's trying to provide, business analysts with up-to-date dashboards, for example. And that should be something that is very easy to integrate into, your current system, your current setup, your current tech stack. So let's make, this kind of high-level idea a little bit more concrete with a worked example. And the thing that I really want to emphasize, and I'm going to emphasize it a lot, is this idea of emergent complexity when you deal with orchestration problems. So what is the example we're going to work through? Just to make everything super clear, super, precise, let's just imagine we're all data engineers. We're working at a cool startup maybe, and we operate some sort of a web service. And that web service is backed by a single Postgres instance. Okay, cool. We have been tasked with keeping that taking all the data in that Postgres instance, putting it into BigQuery, which is going to be our data warehouse for analytic queries, and then providing analysts some way of interacting with BigQuery. Maybe it's directly through SQL. We're not totally sure what that looks like quite yet. So that's our goal, and that's the only thing that we want to achieve. So what is the positive engineering here? So these are valuable uses of time. This is why we're a data engineer. We want to think about schema design. What does that BigQuery schema look like? Is it exactly the same as the Postgres schema? Are there any constraints that we need to understand about BigQuery? Are we putting ourselves into some sort of vendor lock-in with whatever design we choose here? Maybe we want to go to Snowflake one day. How to keep the schemas in sync. So what if someone adds a new column to our Postgres table? How do we know that happened? And how do we include that in a seamless way into our data warehouse? How to handle deletes. So if we're just taking copies of data, then we have to do some work to infer whether someone deleted something. And maybe that's an interesting thing for us for whatever reason. So that could be a tricky problem depending. Managing and tracking costs. If we're exposing this to analysts, we probably need to kind of have a careful eye on the query costs. Maybe they're writing bad queries, so maybe we need to constrain that a little bit. So that's a good use of time. And kind of on the same page, just we need to make sure that the less technical folks that we're serving these insights to have some sort of self-service dashboards. Like I said, could be direct SQL, but probably not. We probably want to implement some interface, maybe Looker. That's a popular use of Looker here. So these are all things that we should be talking about, but I'm about to tell you a story or we don't spend a single minute talking about these things. So the first thing we do is the most natural thing. We write a Python script. And this is a high level, no need to write the exact code here. The point is we have a script. It has a couple of things in it. I don't want you to get the sense from this image that this is a particularly well-written script. It is just a script. The script does 4 things in order. Who knows? The point is it doesn't matter how well or not well the code was written. It loads the schema from our Postgres database. it gets the current batch of data that hasn't been put into the data warehouse yet. It transforms it to CSV. That's what we've decided to do. And then we take that CSV file and upload it to BigQuery. So really straightforward, probably took us a while to actually get all this together. We had to learn some BigQuery, but we've ended with this nice artifact of a Python script. Great. So we're a small company. I'm just going to run this whenever I feel like it. When an analyst comes to me and says, hey, I think my dashboards are stale, I'll just go Python, run this script, gets up to date over the course of however long it takes, maybe 10 minutes, and we're off. And maybe I'll just decide to do this once a week. I set a little calendar reminder, nothing fancy. Okay, so kind of sticking with our theme of if you give a mouse a cookie, if you give a data engineer a task, they're going to ask for Python. Python's definitely the most popular tool in the data engineering, data science space. So almost certainly shows up in your tech stack early on. Okay, well, good news. Our business is growing. And we just need to automate some of this so that we can spend our time working on the other things, like keeping up with the schema, for example. Easy. I know how to do that. I'll use cron. Little cron string here calls my ETL script, and I have it set to run at 8 a.m. every morning. Okay, great. Seems like a really simple solution, right? The exact perfect use case of cron. So give a data engineer a task. They're going to now ask for cron and ask for more computers because I need to run this somewhere and my laptop is probably not the right place for it. So what have we just done? We made a seemingly incredibly simple decision, but that decision has a lot of costs that are going to build up over time. Oh, just to go back here, if you give a data engineer a task, they will ask for Python first. Next up, ask for cron to do some basic automation. And lastly, ask for more computers to run these things on. So what complexity have we introduced without actually realizing it? First off, we have to provision some infrastructure, maybe an always-on virtual machine or something like that. Proof of work. So with cron, it's kind of a quiet service, right? We're going to have to figure out how do we know for sure that our script ran successfully every day at 8 a.m. I'm going to have to do something there. Okay, let's say that the work didn't complete and I can see that our data warehouse is stale. Okay, where do I go to figure out what happened? Do I need to change my script? Is there a schema out of date? Maybe it ran halfway and there's a CSV file lurking around on one of my machines that I need to find. How do I do that though? So similar, how do I detect when the job just didn't run at all? So absence of work is a really hard thing to catch. And we're smart. We say, that's no big deal. We just need to add some logging, and then we can just look at the logs to see where things stopped. We'll write to a file when we're done, and so then if the file doesn't exist, in the morning, I know that the job didn't run. Maybe add some try excepts. Sending a Slack message is relatively easy with a post request. I can write that code, no big deal. And of course, I'm still going to have to check in on this every few days to check that the files exist and all of that good stuff. So we made a very simple decision, but we're already starting to write a lot of code that is just around the surface area of the task at hand, which is moving data from one place to another. Well, good news. The analysts love the dashboards I'm providing, or that we're all providing, and they want more. 8 a.m. every day is not enough for their needs. I know how to do this. I'm going to speed up the cron schedule. Super simple. So this cron schedule, in case you're not familiar, is going to run my script every 30 minutes. So now data is always no more than 30 minutes stale. Great. So did we introduce any new negative engineering in this speeding up of the schedule? I would argue that we did. We need even more logs that we have to sift through now and even more files. So we're going to have to start thinking about how to track all of these. We're still going to have to do manual check-ins to make sure work is happening. One thing is all of a sudden, now that I sped this up, I'm starting to see more failures. So I'm seeing something like 1 out of every 10 is not succeeding for some reason that I haven't quite figured out yet. Because we have poor visibility into exactly what's happening. The logs just kind of stop, not totally sure. It seems like maybe the process hangs. So, no big deal. We'll just do some more stuff. What are we going to do? We're just going to add more logging. now I'm gonna request from my manager that we need to wire up a logging service, maybe Elasticsearch or something, because I want every single little detail logged. And this will allow me to make queries based on timestamp, which is something that I feel like I need now to see, if I can detect any trends in these failures that I'm observing. And so if you give a data engineer a task, now they're asking for a logging service to wire up to this one little data refresh. Sorry, I shouldn't say little, it is hard, but this one task that they have of keeping this data warehouse up to date. The business is still happening all around me as I am obsessing over these dashboards that I'm providing, and the org is maturing. We're moving off of static always on servers, and we're going to Kubernetes. Everyone's excited because they think Kubernetes is the coolest thing and solves every single problem under the sun, regardless of whether this was a good idea. Doesn't matter. It's being forced on us from up above. So no big deal. This is exciting for our own career growth. We just need to containerize our script. So learn a little bit of Docker. We need to figure out how to keep these scripts up to date in case I make changes to them, like maybe related to the schema. We need to learn some YAML. That's definitely going to be fun and exciting. And we need to maybe learn some networking to figure out, okay, how do we talk to the database from this Kubernetes cluster? Because the VM was maybe sitting right next to both databases in the past, and this feels a little more complicated. And a totally different team is managing this cluster, so we have to talk to them. So you give a data engineer a task, and now they're asking for GitOps so that they can do these auto deployments to this Kubernetes thing that they've created, which is, at the end of the day, still just running cron and still has a lot of the proof of work visibility problems that it had before. It just is running on bigger machines, basically. Okay, the story continues. We are crushing it in our job. And now analysts, 30 minutes stale is now not even enough. So they're requesting the ability to manually refresh this data, which is great. So no big deal, cool new problem to solve. We just need to set up a web server that they can hit. So this is going to send some sort of post request and then run our script manually. We need to configure some auth for that server because we were dealing with some slightly sensitive customer data, and we don't want people to just be spamming this service, touching our production database. And so turns out that a lot of the failures we were experiencing due to the fast schedule was because sometimes the jobs would take longer than 30 minutes. And in that world, we were opening up more and more connections to our production database, and those connections were eventually overwhelming the database. And so we couldn't open new connections, and that explains the freeze that we were seeing. So to get around that, we're going to introduce another new piece of infrastructure, PG Bouncer. Great tool for pooling connections to Postgres. Yeah, exactly. Someone mentioned they're feeling the growing needs and responsibilities. The pressure is on. We're having to learn a lot of new stuff very quickly. And, once again, the task itself in words was simple. Keep the data warehouse up to date. And last, but certainly not least, because of how much our business is growing, multiple Postgres instances are being introduced. Okay, so this introduces something that also seems really simple, and I'm going to kind of table our problem buildup here, which is parameterization. We need to maybe pull data from one instance and upload it to the data warehouse, maybe a different instance. Maybe they need to run on 2 different schedules. And maybe analysts want the ability to manually refresh from a specific instance whenever they're dealing with their dashboards. So parameterization, which we haven't thought through at all here, probably going to introduce some CLI flags for our cron script and just put them on different schedules. That would be my go-to if I'm living in this mindset. But I think I have sufficiently exhausted you enough that there have been a lot of things that have built up for this seemingly simple task. And so last, if you give a data engineer a task, they're going to ask, can I bypass the proxy for my web server because I can't quite figure out the networking? And of course, they're going to have to go back and forth their DevOps team on whether that is a secure thing to do or not. It probably is not a good idea, and you're going to have to learn some more. So all of that being said, we were trying to keep up with the pace of business, and at the end of the day had created this really large behemoth of infrastructure, all of which was really cool, but maybe wasn't the best use of our time, especially given that we have these new instances coming online soon. So if we were going to postmortem this and take a step back, and so this is the moment, by the way, that we crack and we say, okay, you know what? We need to go look for an orchestration service or some sort of workflow tool because I can't keep managing all of this stuff and I need a dedicated framework for it. And so at that moment, we have to decide what our reasons for doing that are, et cetera. So we kind of look back over our journey at the company, and here are some things that we take away. We amassed a lot of custom code, which I would say is all tech debt. And so think about this. In this kind of last instance where these new instances are coming online and I'm still trying to give my analysts the ability to manually refresh, I now have to make a prioritization decision. And that decision is between actually giving analysts the ability to refresh data that matters to them and that was my original task, or going and building, a web server and figuring out how to parameterize cron scripts and things like that. That prioritization decision shouldn't have to happen because the first one is the obvious, higher priority. My job is to keep data up to date, make sure the schemas are well understood, et cetera. It's not building web servers. So it's not just that it's custom code that we have to maintain, which didn't even bother going into for this. All of this has to be maintained, and I guarantee you every step on the way had at least 3 bugs. But it's this prioritization decision we have to make now in maintaining those systems. There's still a lot of edge cases left on the table. Who watches the watcher? What happens if the process dies? Scaling. What happens when this continues to scale and our VM or our Kubernetes cluster just can't handle it and we have to run thousands of these or something? New use cases is a really big one here. Every single thing that we built in this story was for one use case. What happens if another use case comes up that's slightly different and maybe the schedule isn't even a schedule? Maybe it's an event-based thing. So how do we fit that into our framework? Because every time we made a decision, we made it in a simplistic way, and we weren't thinking to the future about how to design this in a way that would satisfy new use cases, because once again, we weren't hired to do orchestration, we were hired to do data engineering. Migrating tech stacks required a lot of work just for the sake of a script. So there's something kind of fishy going on there. Like, it shouldn't be that much work to move a script from one place to another. And of course, has to be said, never say just. Nothing in engineering is just something. There's always lurking emergent complexity in the thing that you're thinking to do. So you should always kind of take a step back and ask yourself, is this a good use of my time, or is there a better way to do this? So those are kind of more on the negative side, like just some things that were becoming problems. What insights do we have from this? So now we're on the market for a new orchestrator, and we kind of have some ideas of what we want to look for. So first, visibility was a key driver of most of our decisions. We wanted to have confirmation of job success. We wanted visibility into failure. What step failed? What did that failure look like? What was the traceback? Just any logs about how much data we're moving so we could start to track some metrics and things like that. All of this complexity grew out of something that seems so silly: scheduling a script. And next thing you know, we're building web servers and talking about auth. So it was a really simple use case that did not really grow in a way that was proportional to what it was doing. Cron and Kubernetes, something that I didn't mention as I was bringing them up, but if you really think about them, they only operate on metadata. Cron needs the location of a script, and then it runs it. Kubernetes needs locations of containers, but then the rest of the YAML that you're working with are things like resource management type definitions. You're not telling Kubernetes any of your business logic. It's just orchestrating the container at a high level. So why is that interesting? Why is the metadata part interesting? And how does this tie into my story of what we're doing at Prefect and the original abstract that Julie said before I started talking? Well, over half of the customers that we see do in fact come from homegrown systems that look a lot like the story that I just told you. They just kind of continue to iterate, bolt on new features, and next thing you know, it's kind of a nightmare of a system that they have to move off of because they just don't have the bandwidth to maintain it. Or there's a new use case that it just doesn't fit into, and they recognize that they're not going to be able to keep doing this. So we took a step back. We kind of looked at the space of data engineering and data science and came up with some product principles based on this. So first is that orchestrators shouldn't get in your way. notice the entire time we were talking, we never really went into the guts of the script, and we didn't even need to. That was just to kind of give us some context for talking about this stuff, but it wasn't really necessary. So orchestration is very much a separate thing from the problem that you're dealing with, which is why I said that it's part of negative engineering, not positive engineering. You should be able to organically adopt new features when you're dealing with orchestration. So I mean this in a few different ways. So first off, once again, our initial use case was simple: run a script on a schedule. Your orchestration tool should allow you to do that with no additional bells and whistles if that's all you need to do. And then if you need to do something like migrate it to Kubernetes, you should be able to do that in an incremental fashion. You shouldn't be forced to go all the way initially. Another type of incremental and organic building of features that's important is the developer experience. You should be able to do some basic tests with your script locally on your machine with no additional fancy setup, just to sanity check your logic. And then, maybe you deploy it somewhere else. Maybe you keep it on your local machine for a couple of weeks initially, kind of in those early days. Maybe I just didn't want to put it on a VM. But your orchestrator should kind of allow you to grow with the tool and with the complexity of your use case. Orchestration should occur via pure metadata API. The reason that I say should here is that cron is such a cool tool, for example, and so powerful because all it does is it runs an endpoint at a given time. And the second you have to start writing, cron code that doesn't exist inside your script, you're crossing a line that makes it really hard to make other decisions because your orchestrator is forcing you to think in a certain way in your code paths. And of course, you're always going to have to think a little bit in terms of your orchestrator, but it shouldn't be so heavy-handed that it forces your hand to make certain decisions. And if you work in pure metadata land and over an API even, you can migrate between tech stacks. You can upgrade really seamlessly because the orchestrator is not living inside your tech stack and is not forcing you to make certain tech decisions. And last but not least is that orchestrators shouldn't care at all about what your tasks are doing, only how they're doing it. The reason that this point I think is so important is that orchestration is such a general purpose problem that the second it takes an opinion or it needs to get involved in the what, not the how, you essentially cut off a huge swath of use cases that you're inevitably going to have with your orchestration tool. And it's going to give you a kind of sort of vendor lock-in where you have to always think in terms of how the orchestrator forces you to think instead of thinking about the positive task that you have at hand. Once again, I wrote a script. It might not have been a good script, and I might not be that good of a software developer to relearn some fancy framework. I might just need something that's dead simple, and that's okay. There's a lot of us out there that we want simple tools that do powerful things. And so, yeah, orchestrator should only have opinions about the how, though, is the thing that I want to emphasize there. And so, kind of last but not least, and I know that I'm kind of running right up against time. So at Prefect, we did solve this problem with something we call our hybrid model. I encourage you to go read about it. From a technical perspective, it involved a ton of technical challenges that we're still, have to think about daily about how do you orchestrate from afar. And that's the reason my talk was originally titled Spooky Orchestration at a Distance, because we do not access customer code or data when we do orchestration. Customers own their execution environment, and Prefect owns the orchestration plane. And everything operates via metadata over this API connection. This is the first time that companies can offload a lot of their negative engineering orchestration challenges to a central service without compromising security or being forced to choose a tech stack. If you're running on bare metal servers, as long as you have Python, you can do orchestration. If you're running in some serverless environment, also great. You can use our orchestration service. And if you want to migrate between the two, all of that is totally fine because it occurs over an API. And last but not least, it empowers users to focus on what they actually care about, the positive engineering that they were hired for, and avoid all of this emergent complexity that we kind of built up over these, over the course of our business growing. And so with that, right on time, thank you. If you find any of these technical challenges interesting, we are hiring a lot right now. And so please check out our careers page on prefect.io.
Awesome. Thank you so much, Chris. This is super interesting. Thank you to everybody in the chat also. Chris, if people want to follow up, where can they reach you, either Twitter or email?
Yeah, Twitter is Markov_gains with a Z. I do come from math, so math pun there, or Chris at Prefect.io.
Awesome. All right, great. Thank you. Everybody, I want to ask you, or invite you rather, to meet us over in the next session. If you go back to the main stage, you'll see a way to enter. This is a session from Crossbeam on why we bet, let me make sure I get it right, why we bet our startup on Clojure. All right, I will see you all there. Thank you everyone for joining us today at the Developers Conference.
Bye. Thanks, Julie.